Hi everyone, welcome back to this session on trigonometry. What we're doing now, grade 12, is we are going to look at some of the exam type questions that you can be asked. Now certainly one of the big sections in trigonometry is functions. So that's what we're going to start with. We're going to start with a question on functions. Okay, have a look at this question. So here you're given the graphs of f of x is equal to minus a half cos x. All right, so let's identify f. There it is, and let's try and trace it out in red. Okay, so we keep an eye on the graph of f, which is in red. So it's given by f of x is equal to minus a half cos x. Straight away I start thinking about things. I see this negative a half, and I see that the value of a is negative a half. Remember, that is not the amplitude. Amplitude is a positive value. It is not a negative value. It is also a distance, and the way to calculate the amplitude, maximum value minus minimum value divided by 2. So those are the kind of things you need to start thinking about when you see just the given information. Obviously, it goes through your head in a flash. And they tell you that g of x, which is the one we're going to leave in black, that is given by sine of x plus 30 degrees. I see, okay. That tells me there's a horizontal shift. And of course, if you watched our other lesson where we revised grade 12 trigonometry, we showed you nicely how the graph moves horizontally when p is positive. So if we've got x plus 30 degrees, the graph's going to move 30 degrees to the left. Okay, and that is now the graph of g. All right, those are the two functions we are given. We've identified them. We understand how they've changed. Now let's look at the first question. So the first question says, write down the period of g. So take a second to just think about the period. Remember, period is a single value. Do not confuse period with domain. So you might have your graph drawn in a domain, for example, from 0 to 180 degrees. It does not mean that the period of the graph is 180 degrees, all right? The period of the graph will be determined by what the value of k is. And it's not necessarily what is always drawn in your question. So your question might be just be drawn in a domain from 0 to 180 degrees, but it does not mean that the period is the same as the domain. Also, another thing that you need to remember about a period of a graph, and I've mentioned this many times, is it's a single positive value. So let's have a look at g. And just when we looked at that marks quickly, I just want to touch on it. We see that it's only one mark. That means this should really not take you more than a minute to do, because if it's taking you more than a minute, it's going to impact the time that you have to spend on other questions later on. All right, so let the marks also be a guideline to you on how long you need to spend per question. G is obviously the graph sine of x plus 30 degrees. Remember that the horizontal shift does not affect your period. So how long will it take for this graph to make a complete sine curve or a sine wavelength? Certainly you can see that your domain here is 0 to 8 degrees, 0 to 180 degrees. That's an interval. That is not the period, right? What is the period for the sine graph? Well, I said to you the value of p does not affect the period. So therefore, for your sine graph, which is sine of x plus 30 degrees, your period is still going to be 360 degrees. This value of 30 does not affect the period. So therefore, your period is going to be 360 degrees. All right. The next question says, write down the amplitude of f. So if we have a look at the amplitude of f now, so f being the graph that we've drawn in red, and we've made a note to ourselves that this was multiplied by minus a half. This function, remember the value of a once again, I will keep repeating it. This value here is not the amplitude. That just is the value of a, right? How do I find the amplitude? Well, all we're going to say is maximum value minus minimum value divided by 2. Okay, so if we look at the cos graph that's drawn here, the maximum value of your cos graph is at that point 180 degrees there. And if you were to calculate it on your calculator, you will see that the value you would get here, if you go across to the y-axis, that value is a half. Okay, so this point here is 180 degrees and a half. So the maximum value is a half, and the minimum value here at 0 is negative a half. So therefore your amplitude is going to be a half minus a half over 2. All right, a half minus a half is 1, a half plus a half essentially, and 1 over 2 is the amplitude. Do not be tempted to say, oh, but there was a half there in front of the cos, so therefore I could have just taken that. Do not do that. There will be times when it is certainly not the case that you can just take the value of A to be the amplitude. Okay. All right. Determine now the value, the function value f of 180 degrees minus the function value g of 180 degrees. Remember, guys, it's so essential that you remember that a trig graph is just a normal graph. It's a function that you've done before. So f of 180 degrees is the same as saying if I was looking at a parabola and I wanted to find f of 2. I would substitute that 2 as the x value or as your independent value and work out the dependent value. This is exactly the same thing. So I can see here that they're telling me that 180 degrees is the value of your horizontal axis, and we need to find the function value. What is f of 180 degrees? And from that, subtract the function value of g at 180 degrees. So if you have a look at your graph, and let's have a look at what's happening. At 180 degrees, which is at that point there, we want to find the value of f, which we already know is a half, and from that we want to subtract this value here at g. Now, if you don't know that that value is in fact a half, a negative a half, how would you find it? All you would do is you'd take 100, remember this is a function value, so all you would do is take that value of 180, substitute it into what you've got for g. G of 180 degrees would be equal to sine of 180 degrees plus 30. I'm just finding the function value. So sine of 180 plus 30, that's the same as sine of 210. You can use special angles, you can use reduction formula, you can use your calculator, but this would be the same if I'm using reduction formula. Sine of 180 plus 30, that's in your third quadrant, so it would be negative sine 30 using special angles. Sine of 30 is a half times by a negative. This point here is negative a half. So you see there's more than one way you could work it out. So therefore they said f of 180 degrees minus g of 180, what is the value? Well, it's simply going to be a half minus a half, which is equal to 1. All right. Okay, the next question says use the graphs to find the values of x in the interval 0 to 180 degrees, which is what you've got drawn, for which f of x minus 10 degrees is equal to g of x minus 10 degrees. So here what you've got is you've got that both functions have moved 10 degrees in which direction? Because p is negative, it's moved the other way. So the graphs are moving 10 degrees in the positive direction. And they want to know for what values will these two graphs still be equal to each other. So all they've done is it's the same functions. They're saying move both of them 10 degrees to the right. And now what will be this new point of intersection? Because remember, just like in functions, this equals means where are the two graphs equal to each other if we subtract 10 from both of them from their function values. Now some of you might be tempted to take the x minus 10 and substitute it into your cos graph. So you'd have minus a half cos of x minus 10. And you might do the same thing for the sine graph and then you try and solve it. Please, guys, don't do that. Because even though we're dealing with function values, look at the mark scheme. You will see that it's 1 mark. And it is not worth your time to try and do a whole long equation by substituting function values in just for 1 mark. Okay, so let that be the guide to you. That firstly, this is something that's already existing. This is a question that can be answered from what I already have. I do not need to do lots of additional work. This is only 1 mark. So all that's happening is these graphs are now being moved 10 degrees to the right, and we're saying, well, now where will they intersect? Well, if we move basically this intersection point 10 degrees in that direction, what is the value of x going to be? Because remember, when you add p, it's a horizontal movement. It only affects the value of x. It does not affect the shape. It does not affect the y value, your function value. So therefore, we're going to say that if I add 10 degrees to that, well then, the new point of intersection, 130 degrees, 9, plus 10, that would give me 140 degrees, 9. That will be the new point of intersection. And all they wanted was the value of x, so make sure you answer the question. X is equal to 140 degrees, 9, and that's it for 1 mark. All right. Now for 4 marks, this obviously needs a little bit more work, question 4.2. So if you look at what they've asked you, where is square root times sine x plus cos x greater than equal to 1? Some learners will look at this and get very frightened because, understandably, it's not something that you were given. It doesn't look like something that already exists with the functions you've been given. So what I want to do is I want to give you some time to think about how you can change the left-hand side of this equation to make it look like a graph that you've already been given in your diagram. Remember, with these type of higher order questions, which is what this is, it's more complex or problem solving type of question, the answers already exist there, somewhere in what you've been given, somewhere in what information you have already. You just need to figure out how to make that information work for the question, okay? So we're not going to do a whole new sum. We're going to think about how I can manipulate the functions that I've got to get to what they are asking me. All right, so I want you to think about that as we take a quick break, and when we come back, we'll have a look at this question. Welcome back, everyone. So glad you joined us once again. Remember, what we are doing is we are looking at some of the trigonometric questions that you had to practice, and we're looking at the solutions to some of these, which are exam type questions. Now, before the break, I asked you to think about how you can manipulate the given graphs to get to this inequality of question 4.2. So just to remind you, the inequality was square root 3 times sine x plus cos x is greater than equal to 1. And of course, we're looking in the interval 0 to 180 degrees. We're trying to solve for x. So where is this greater than equal to 1? If you just look at that inequality by itself, it requires quite a lot of work. But if you remember that you were actually given the graph of sine of x plus 30 degrees, it might then not require so much of work. Why do I say that? Well, this I recognize as a compound angle, sine of a plus b. So the expansion of sine of x plus 30 is sine x times cos 30 plus cos x times sine of 30. And what you should also realize is that cos of 30 and sine of 30 are special angles. Now, we always try and encourage you not to use the calculator, but if you're really stuck and you don't know what cos of 30 is, you can look it up on your calculator. However, it is a special angle, so you should know that the value of cos of 30, or you should be able to work out using either your triangles or your diagrams, you should be able to work out that cos of 30 is square root 3 over 2. So this will become sine x times root 3 over 2 plus cos x times a half. So we're getting somewhere now. I can see the root 3. I can see, okay, well, there's a half now that I'm not too happy with, but I can see the cos x, and I'm happy about that. And I see that how this is different from the inequality is that there is no fractions. There's no value of 2. So what must have happened to that 2? Well, it must have been multiplied throughout the question. So how do we get this expression to look like what we've been given? Well, we need to get to sine of x plus 30, which is what the question gave us. So what we should do is, in fact, divide through by 2. Remember, an inequality is similar to an equation. You can divide through by 2 if you do it onto both sides. All right, so I divide through by 2, and I end up with an expression that's very similar now to what I've worked out as sine of x plus 30, I get root 3 over 2 sine x plus cos x over 2, which this can be rewritten as, because they're multiplied together, is greater than equal to a half. Aha, so now we're getting somewhere, because then I can say that this is basically saying to me, where is sine, and let's just go back there, where is, in fact, we are running out of space on this slide, so let me clear up, see, let us clear up the ink on this slide, there we go, so that's a lot better. And we're going to say, okay, so that we divide by 2, that we divide by 2, and the right-hand side. And now this looks similar to sine of x plus 30 degrees on the left-hand side, greater than equal to a half. And you see how this now goes back to something you were given. We were given the graph sine of x plus 30, and what we need to work out is where that graph is greater than or equal to a half. Okay, so we took a complicated expression and then simplified it into something that made sense to us. All right, so let's see if we can get the ink off this slide. All right, without jumping around too much. There we go. All right, so we're looking for where the sine graph g of x is, we said, greater than or equal to a half. Where is a half on the sine graph? Did we identify it? Yes, we did previously, but let's just remind ourselves that a half would be at that point there. Okay, we also know that a half was, this was negative a half at this point here. Okay, so where is the sine of x plus 30 graph greater than or equal to a half? So it's obviously all of this section here, until the graph hits the function value of a half again, so in line with this point here. And then the graph starts tracking down again and starts becoming less than a half. So what value of x would give me a half at that point there? Now some of you, if you are battling to work it out, certainly you can substitute into your calculator and use your calculator to work it out. But the value, if you know how your horizontal shifts, it should become quite clear to you. If you understand your horizontal shifts, you should understand that this value here of x is actually 120 degrees. How do I know that? Because if I put 120 in place of x, I get sine of 120 plus 30, which is sine of 150. Sine of 150 degrees is a half. And I know that because dealing with horizontal shifts, remember your graph moves 30 degrees in this case to the left. Okay, so therefore this is 120 degrees. So everywhere between 0 and 120 degrees, do you see that the graph is either greater than or equal to a half? Now, when you write the answer here, this is not a single value. This is an inequality that we're dealing with, or an interval. So therefore, it's not going to be x is equal to 0 and x is equal to 120. No, it's going to be x is less than equal to 120 degrees, greater than equal to 0, or x is an element of the interval from 0 to 120 degrees. So there's two ways we could write the answer here. It's either going to be using inequalities, x is less than equal to 120 degrees, greater than equal to 0, or if you understand interval notation, and hopefully you all do by this stage, x is an element from 0 to 120. And importantly, guys, the next question is very eager to come up. Importantly, guys, what we need to remember is we are using square brackets. And the reason we need to remember to use square brackets if we're using interval notation is because that shows us that the end values are in fact included. All right. Hopefully you all understood that question on trig functions. Trig functions are a big part of your final exam, paper 2. Let's move on to the next question, which we saw a couple of times now on screen. Determine without using a calculator. So what type of question is this? Just by a glance, having a look at it, it's reduction formula, okay? Reduction formula, remember you've got to use your CAST diagram to help you. Your CAST diagram tells you in which quadrant each function is positive or negative, okay? So therefore, what we need to remember to use here is this one, A, S, T, C, all stations to Cape Town, CAST diagram. In the first quadrant, all angles are less than 90 degrees. In the second quadrant, all angles are less than 180 degrees. In the third quadrant, everything is less than 270 degrees. And in the fourth quadrant, all angles are less than 360 degrees. Okay, guys, so what I'd like to remind you here is just on the axis, this point is 0, 360 degrees, okay? This is a measurement of 90 degrees. Up to here, it's 180 degrees. And here we've got a value of 270 degrees, so that you can see how we come across these reduction formulae being positive and negative in the different quadrants, which functions are positive and negative. You can see that everything to the left of 180 degrees is 180 minus theta, and everything to the left of 270, but greater than 180 degrees is 180 degrees plus theta. We could also say that as 270 degrees minus theta, but it's not something you really get examined on too much. All right, let's quickly get into the question because we don't have much time left. We have a look at the values that we've been given, and we see that we're dealing with some double angles. So we keep in mind our double angle formulae. Let's get straight into the reduction. Sine of 2x will stay the same. So we just simply bring that down. Cos of negative x, now all of your negative angles that are acute end up in the fourth quadrant. So simply to find what the answer is of cos of negative x, because cos is positive in the fourth quadrant, your answer here will simply be cos of x. If you don't understand how to work with negative acute angles, just simply add 360. 360 minus x, fourth quadrant, cos is positive there. Plus we've got cos 2x. Sine of 360 minus x, we identify in which quadrant 360 minus is. Okay, that's the fourth quadrant. In that quadrant, only cos is positive, so therefore sine must be negative. So I reduce this to negative sine x, and then I divide, oopsie, let's call that up, I divide by sine of 2x. Okay, how did I just get sine of 2x? 180 minus is the second quadrant, and sine is positive there. So now, guys, we need to, in fact, let's call that slide up. Sine of 2x, using my double angles, will become 2 sine x cos x, because remember that is the expansion for sine of 2x, minus, we've got cos 2x times sine x, and that was all over sine of 2x, which we can simplify to 2 sine x times cos x. All right, guys, so what we're going to do is I want to leave it here, and I want you to carry on from here. It's a simple manipulation and simple algebraic techniques that you've got to get from here to your answer. All you need to do is think about, can you take out a common factor? If you take out a common factor, what will you be left with, and will you be able to then use identities to get you to the final answer? So I want you to do a little bit of work here to get you to the final answer. Thank you so much for joining us today. That's it, and I hope to see you again next time.